I recently learned about some challenges with promise rejections. I thought it would be interesting to share. For start, if you have a promise that is rejecting and you are not catching it, it may crashes your app. Let's, for example, define p1 promise.reject and error 1, right? If I run this, for example, let's say tsx index.ts, you see we are getting unhandled promise rejection error. Obviously not a desired behavior, right? It can get even more confusing if you have more code after a promise rejection. Like for example, let's say I have a console log and I'm going to say amazing day. If I save, let me run this again. If I run this time, you see amazing day is printed on the console, but still we have this nasty error. Let's analyze what is happening. Since JavaScript is single-threaded, it starts from the root on the top. It creates the promise rejection object without executing it. Then it goes to the next line, logging amazing day on the console synchronously. And after that, it's now ready to execute the promise. It goes and executes it rejects with error 1, and we ended up with this unhandled promise rejection error throwing. Well, what is a fix? We can go ahead and catch the error. Let's say I'm going to console log this. If I save and run this again, we are now seeing amazing day and error 1. But the issue is nothing hints us that we forgot to catch a rejection before running the app. You may think, well, this is JavaScript. What do you expect? Let's use TypeScript. But TypeScript is not helping us here. Let's add some type hints. So let me add, for example, a type for p1, promise dot, this is going to be a promise void, right? Promise is not showing any information about the error path. Well, this void is showing the output of the good path, but the rejection path, there is no place for it here. What we were hoping to get is, all right, the good path is void, but the error path, since we are mentioning it by error 1, would be, for example, a string. But this is not the promise structure. Promise has only one type parameter, and that type parameter is for the good path. The issue is promise is not modeling the error path at the type level. Let's look at a bit more complex example so you can see how much JavaScript and TypeScript code bases, which are designed directly with promises, can be dangerously fragile, especially when multiple people work on the same code base. First, let's create some tools. I'm going to create a function called resolve, which it looks like this. This function receives some time, a number as a wait time, a value, and what it does is it's going to return a promise, and it's going to resolve this promise after a certain time. So set timeout, and what it's going to do, resolve this with the value, and wait for this wait time. Let's do the same thing with reject. So we want to wait a little bit and then reject with an error. New promise. We only care about the rejection path. Set timeout. We're going to reject with an error and wait time. So again, what resolve and reject does is that when we call it, it's going to wait for some time and then it's going to resolve or reject with the second parameter. Next, let's define a function called, for example, do stuff. And inside here, I'm going to define my first promise, which is going to resolve in a second with the value of hi. And we're going to have a second promise, which is going to reject after, for example, let's say half a second with error 1. At the end, what I'm going to return is I'm going to say p1.then, and we're going to ignore the value the promise p1 is resolving with, and I'm going to return p2. At the end, I'm going to call do stuff. And what I'm going to do is, hopefully I'm going to catch the promise rejection. Just to review again, P1 is going to resolve after a second with a value of high. Then we're going to have another promise P2 that is going to reject in half a second with error 1. And what do we want to do is that we're going to wait for P1, and P1 is going to call, and then JavaScript is going to call this callback after a second, which at that point, P2 may already be rejected, and we're going to return P2, and hopefully the whole thing is going to flatten, and do stuff is going to return a promise. And at the end, we are catching it with console log. This is what we are aiming for. But if I run this, you see we are getting again unhandled promise rejection. And to me, this was pretty confusing. So let's try to fix this, right, step by step. Let's go and say, all right, I'm going to catch P2 here, and let's do console log here, right, again. And if I try to run this again, you're going to see that I'm getting again unhandled promise rejection. The only solution is to come here and catch it right after we create it. Now, if I run this, we are getting error 1. You see what happened? We thought we designed our code correctly, and JavaScript didn't help us, TypeScript didn't help us, and we found the unhandled promise rejection after we run our application. And if we think of it from JavaScript perspective, its design kind of makes sense. But we want to write reliable production-grade applications. And feeling that it's possible for scenarios like this to happen unwantedly and language is not protecting us is scary. Just imagine getting one of these unhandled promise rejections in production, and you need to figure out where this is happening inside your code. At least not a quick and easy investigation. So what could be a solution? Well, we can go with some other language that protects us out of a box for these asynchronous promise-like needs. This solution makes me sad since I love TypeScript. So let's imagine I didn't mention this. There seems to be some linters available to help us capture these situations, so that could be an option. Another solution could be attaching a catch block as soon as we create a promise. This could fix the issue, but it's not a good general approach. You are collapsing a rejection execution path on the good path of your code, meaning you need to provide a good default value for errors and rejection cases, which is not always possible. So what we can do? We can abstract promise into another structure that models good value and bad value at the same time. This structure could immediately capture rejection and put the execution in a non-crashable path, but it still lets us to discriminate between a good value and bad value. Basically, we are keeping the good value and bad value in a same value, like a union type. If you have followed my functional programming course, this should sound familiar. Just to mention things, we can have an either structure that keeps a bad value and a good value under the same type. And the way it is organized is like, for example, we say there's a tag that says, for example, this is bad, and the error is E, and it's a union type, and we have a tag good, which is a good value, and we say value is of type A. This is either. And for modeling asynchronous operations, we have a task structure, which similar to promise only has one type parameter. And the way we model this is like it's a tongue, and it returns a promise of A. Now, if we merge these two, it's going to look like this. What we are looking for is, for example, a TaskEither structure that has ENA, and we are looking for task of either of ENA. And now, since we are capturing the good and bad value under either, and so this promise, like if I want to expand this, let's do that. Task either ENA would be a thunk promise of either of ENA. And we can expand this, but I think you got the idea. What we are doing is we are capturing rejection path and the resolving path under a same value. Another solution could be using libraries like Effect. If you have followed my Effect course, Effect structure also fixes this challenge with unhandled promise rejections. Just to mention it, Effect structure looks like this: A for good value, E for error value. It also have a requirement, but for the sake of this video, we don't need to consider it. For the last note, the way I look at it is JavaScript is similar to when engineers used to use assembly to code and create applications. It's not intended to write enterprise and production applications with it. That's why TypeScript came along. But apparently TypeScript still has gaps and not abstracted enough to address situations like this. And this is why we have Effect. Effect is the abstraction we were looking for to write production-grade applications without worrying about these promise rejection exceptions. And with that, thank you for watching this video. Please like and subscribe, and I will see you in the next one.